Okay, so let's get started. I'm going to be talking about Chicago Boss, which is a web framework for Erlang. So in order to talk about Chicago Boss, kind of have to understand Erlang first. So we'll start with that. I'm going to try to cover a lot, so once we get to the Chicago Boss demo, we'll go as far as we can, and if we run out of time, then we can save the rest for later. I know Adam did a pretty good presentation last time on Erlang, so hopefully you retained some knowledge from that. I would recommend going online if you're interested and reading the free ebook, Learning Some Erlang for Great Good. That's probably what helped me out the most as far as getting started with Erlang. So some of the Erlang features, Erlang is a functional programming language, so functions are first-class citizens. Basically, it avoids changing any variable data once it's assigned. And there's this concept called referential transparency, which basically means that a function with the same parameters should always return the same result. And it tries to stick with that. Erlang in general tries to stay true to functional programming principles, but it's also like practical enough to go away from that for real-world problems. So, for example, if you had a function called today, you wouldn't want it to return the same result every time because tomorrow should not be the same as today. So for things like that, it's sensible. It is a managed language. It also has, like a lot of traditional languages, greedy evaluation. So expressions are evaluated as soon as a variable is bound to the expression. And once that variable is bound, then you can't change it at that point. And dynamic typing basically just means that every object is, or every variable is bound to a object and not a type. So that's kind of different in some of the languages that we're more used to. So it is pretty old. It was created in 1986, and open source went live on 1998, I think. But even though it's so old, it's pretty advanced for its time. It's seasoned. There you go. It's tested. So you can do millions of simultaneous connections and processes in under a second. You can also update your production code without any interruption to the server while it's running, which is pretty cool. And the server basically never crashes because of the way that exceptions are handled in Erlang. You'll hear a lot of the just let it crash. Basically that means if any exceptions happen, just let that process crash and then just restart it. So it actually makes your code more robust because you're not worried about spending all this time trying to figure out every possible bad thing that could happen. If it's not like something you'd expect, then it's just going to crash and restart. So it's pretty secure code. So if Erlang is so awesome, then why doesn't everyone use it? Might be a question you're asking yourself. It is a functional language. Lots of people don't like functional language, mostly because you don't have your for and while loops. You have to use recursion. And if you really bend your brain, then you have to use tail recursion, because that's even better, but it's pretty crazy. There's no built-in syntax for dictionaries or hash maps. Also, if you want to write any type of server, you have to learn OTP, which is just another thing. There's also, since the language was built specifically for telecom stuff, it doesn't have strings as we know it really. I believe strings are just arrays of numbers that correspond to characters. So it's really not good with string manipulation. But one of the cool features is the actor model. So you can imagine actors as being, if they were people, they'd be sitting in a little dark room passing mail to each other. They wouldn't know about each other, and you would be asking someone else for very specific tasks to do. So they're very good at their tasks, they don't mess up, they don't step on each other's toes, and that's how we can do all this concurrency and simultaneous stuff without making a lot of mistakes. So every communication is explicit, traceable, and safe. So to get Erlang, the standard distribution has all this stuff in it: OTP, web server, all the dev tools, compilers, testing frameworks, etc. So, there we go. Go ahead and uninstall it first so we can see what it looks like when you first install it. So on the Mac, really easy, brew install Erlang, and then boom, you're ready to go. You'll notice that it's talking about some manual stuff here. If you want to see that, it actually has pretty good documentation. Do the manual, and then you have to pass it some section like lists. And then it'll tell you all about lists, functions you can use, stuff like that. So in order to get into the shell, the Erlang shell, just type Erl, and then we're in. There's a couple different ways to exit the shell. One is just Q to quit. You'll notice the period at the end. That's how you terminate Erlang functions. That comes from Prolog, I think, which is a really old language, so it's kind of hard to get used to, but it's not that bad. You can also do your Control-C. It'll give you some options. You can just say abort. Another useful thing you can do is Control-G. So if you have a process that's getting blocked and you can't do anything in your console, you can always push Control-G. You can see what's available. So basically, you'd want to kill the job. You might want to start a local shell, and you could list all the jobs that are running, just so you know the name of it, and then you can connect to a job, and then just pass in the name that you want to connect to, and then boom, you're back in, ready to do whatever you want to do. But here, you can also exit the shell by using Q. So 3, 4, 5 different ways to exit. So let's talk about some Erlang components. So numbers, you got floating point numbers, you got integers. Normal rules of precedence apply, so if you use your parentheses, it'll evaluate the inner parentheses first, multiplication before subtraction, all that stuff. Another cool thing you can do is get different base values. So you would pass in the base, do a hashtag, and then give it a value, which is pretty cool. So, for example, go back into our shell. You can do all the stuff like addition. You can do stuff like that. And like the order of precedence, we'll say 50 times 100 minus 1999. Totally botched that. So that's 1. If we end up changing the parentheses around a little bit, see the order of precedence takes control there. The base stuff I was talking about, so enter the base, hashtag, and then if you want to see like a binary value, terminate. So there's the value of that binary. You can do any other base, so base of 8. Let's see, even 16. Kind of interesting stuff there. As variables, they have to start with a capital letter. Again, you can only assign the value once, and then after that, you're essentially pretending to assign stuff to it as long as it's the same value that it was originally. There's a concept called pattern matching. That's kind of what it does with the pretending. It tries to match the sides. It says, is this really equal to that?
So if it doesn't, it's just error.
Yeah. Okay. And if you need to clear a value, you can do so by using that little f function down there. You can pass in the variable name if you want to just do 1, or if you want to clear all the values, you can use that other one with no variable specified. And again, this is only good in the Erlang shell. So it's unbound right now because we didn't actually set things. So we'll say, hey, I'm equal to 1. We could also say uno. So now uno is equal to 1 as well. We can also do cool stuff like 2 equals 1 is the number 1. Now we'll see that 2 equals 2. Here's your exception. And then, again, it has to be uppercase as well. So, moving on. We also have this concept called atoms. This was new to me. These begin with a lowercase character. You can kind of think of them like constants almost, where the value is equal to the name. You could do, if you don't want to use lowercase for whatever reason, you can actually enclose it in parentheses, in apostrophes, and then it'll be valid. And the benefit with atoms really comes in when you combine it with some data. So you have an ID as an atom, and then you have some data. We'll see that in a little bit here. There's also reserved atoms, so some we'll see in a minute here, like and, XOR, stuff like that. So this is a valid atom. You could do underscore. You can do and sign. So it has a special symbol in it, so that will not. However, if we did want to do that, we could do apostrophes, and it's valid, even though it says it's not. It really is. So those are atoms.
What do you use atoms for? Are they basically just variables as well?
Yeah. So the name of the atom is its value. It's kind of like a variable, but again, like the most useful thing that you do with it is combining it with other data to give it like significant meaning, kind of like key maps almost in a way. But I'll show that in a little bit here. We also have Boolean logic. So true and true is true, false, that kind of stuff. Short circuit operators will only evaluate the right-hand side if necessary. Equality and inequality, the symbols are a little different from what you're probably used to. Instead of double equals and exclamation equals, it's colon in the middle of equals and a forward slash in the middle of equals for not equal. And then exact equality is double equals and forward slash equals. What we're used to is the triple equals or the exclamation, the double equals. There's also, of course, comparisons. You'll notice on the end there that it's equal less than, which is kind of backwards from what we're probably used to. It's one thing that might trip you up if you're doing this. And then you can basically compare anything. So numbers are less than atoms, or less than references, or less than functions, and etc. So save some time. I think that's pretty straightforward. So tuples was another new concept to me. Basically, the form is the curly brackets and then a comma-separated list of elements. The underscore is an anonymous variable, which kind of acts as a wildcard. You could think of this like a set amount array almost. So we'll demonstrate that one. So you can do, we'll say x equals 1, y. You'll notice that if you do comma-separated expressions, it'll evaluate both of them, but it'll only return you the result of the last one. This is actually 1. So now we can do something like point equals And then to demonstrate wildcard, you could say x anything, and it'll return 1, 2, the wildcard thing. You could even just say, but something that's not valid would be doing something, or the numbers are different, then you get the matching errors. Lists are similar, except they're wrapped in square brackets, and they also are easier to like build up because you have heads and tails. I like that graphics. I had to have a reason to stick it in there. So essentially, the head is the first element in the list. The tail is everything else. So that second bullet point there is saying that term 1 is the head of everything after that pipe. Term 2 is the head of everything after that pipe, and so on. You can go indefinitely. They also talk about proper lists, which basically means that it always ends with an empty brackets at the very end.
Is that a requirement for lists?
Not necessarily, no. But for some things in programming, it'll want you to do those proper lists. So examples of lists. Well, if you want to see, okay, so a regular list is something like this. Oops. Get to terminate. If you want to see something interesting, you would expect that to turn 233, but no, it actually corresponds to a character. As long as every number in the list actually corresponds to a character, it'll return the number or the actual characters instead of the list. If one of them doesn't correspond, then it will just return the numbers. It's kind of a frustration that people have with Erlang. You could also add stuff. So if you have a list, and then you just do 2 pluses, 3, 4. There's our new list. Could also subtract. So interesting thing to note is that it's right associative, so it'll start on the right and say, okay, I have this 2. I'm going to take all the 2's out of everything on this left side. That might be actually backwards for you guys, but so that was kind of weird. But there's also a thing called list comprehensions. So it comes from set notation. That's the first bullet point. Second bullet point is set notation simplified a little bit, but it allows us basically to pass in patterns and conditions and create new lists based on that. So some simple practical examples might be we have a pet shop, and in our pet shop we'll have a list at 19 and we'll say the dogs cost $35.99. Another tuple, and we'll say that our rats cost like okay. Oops. Okay, so we have our pet shop. So then we can do something like item. We'll add and item. Oops. Pet shop. Price conditions. Price has to be 4. Be equal to less than, say, 30. So here we're creating a new list based on the items in our pet shop, where the price is between $4 and less than $30. So cat's the only one we could get. And you'll notice that it's 21 whatever, not 19.99, because we added tax to it as well. So, so another concept to know in Angular is modules. So all the URL files are modules. You basically declare the module by that name and then attribute, and we'll see a lot of these in a second. Actually, they're always avoid circular references. This was another graphic I thought was pretty interesting. You have to think about it for a second, but his thing is it makes the code harder to maintain when you have all these circular references, and just try to avoid it. So compiling, this only works in the shell. You use that C module. To call a function, you would say the module name, :function name, and then pass in any arguments you need. And you could also see metadata about any module by using that module_info function. So Erlang has some built-in functions. Let's see, so we have Erlang. Module has an element function and arguments of 2, and then a tuple will say a. And then that basically, you can see that just returns the second element. So that's how you call a function within a module. That's kind of a crash course into really basic stuff in Erlang. This is a full module example. So we have the name of the module. Actually, I'm sorry, that's actually always, you want to say -module and then name your module. In this case, we're calling it useless. The export, it's kind of like, an interface to say, all right, you can use the add function that has 2 parameters, you can use the hello function that has 0 parameters, so on. Another thing, if you're just learning Erlang, you can just say compile and then export_all, and that will just, any functions that are in there, you can use them. And then, of course, we have our add function, which basically just adds a plus b. And then we have another function down there, IO format. IO is another module. It has a format method that basically prints out to the console. So that is our module example.
And the double percent is a comment?
Yeah, actually 1% is fine.
Okay.
But yeah, that's how you comment out stuff. So Erlang is big. We just kind of touched on the first part of what that Learn You Some Erlang for Great Good talks about. There's a lot more to it. But I think we know enough to try to talk about Chicago Boss at this point. Oh, not sure what happened there. So, Chicago Boss. For learning Chicago Boss, the guy who wrote it, Evan Miller, wrote a really good PDF that's available on chicagoboss.org. Recommend going there to learn all about Chicago Boss. So, what is it? Basically, it's just a compiler chain and a runtime library for Erlang web applications. The name was inspired by Tokyo Tyrant, which is a database. He said he liked that because it sounds political, and he's all about how technology is power. And I watched a webcast that he did. He was talking about stuff like that. So he also said that Chicago Boss is kind of like, so Chicago Boss to Ruby on Rails, kind of like Nginx is to Apache. So it's kind of like trying to replace Ruby on Rails in a way. Actually, the interesting thing about Evan Miller is about 6 months ago, he kind of resigned from the project. So, which was kind of reminiscent of, our FUBU. Went on the Google groups and he's like, hey, I had a great time, leaving it in good hands. Everyone's like, thank you so much. It's kind of funny. And he also said he wasn't even going to use Erlang anymore because he's like, well, I was just using it for Chicago Boss. So I'm like, well, that's so great. Why did you have other things that were more important? But just kind of an interesting side note there. So yeah, let's keep going here. So Chicago Boss tries to make Erlang accessible for hackers who just want to write a website without, needing to learn OTP and all this stuff. It uses code generation to get around the hash map issues. Takes care of all the OTP stuff for you. Some of the goals that he stated in that webcast I was talking about, he wants to reduce a typical website's operational cost by 90%, which he thought was conservative, and some of the people in the audience thought so too. So basically right now, if you want to run a large website, you have to have all kinds of infrastructure, operations, bureaucracy, all that stuff. But he's hoping that with Chicago Boss, you could just have a small team and a massive website that scales well, performs well, all that kind of stuff. So talk about some features. Has advanced object relational mapper, lightning fast templates. They use Django HTML templates. Automatic recompiling. If you're using the dev server, you'll have some decent error messaging going on if it crashes or whatever. There's routes for constructing URLs and handling requests. There's full frameworks for sending and receiving email, built-in message queues. There's also testing, so they have what's called Erlang, or eUnit, which is Erlang unit testing. They also do functional testing. And it has a first of its kind event system for monitoring the data model. So his claims are that websites are fun to develop, they're efficient, there's no crashing or memory leaks. You can easily write something like a chat service with Erlang. That's where it's really good at, stuff like that. So the architecture, so basically we have a server hosts one or more Chicago Boss applications, and an application has the MVC stuff, so controllers, views, models, URL routing, a whole bunch of other stuff that we'll see. And apps can share data, so they talk to each other. Whoops, went too far. So it also says that recursion, yeah, it's not fun, but it's hardly used, really, in everyday web programming. Most of the time you're just passing information back from the database to the application code. So again, CB application has a lot of parts. Interesting thing, it also includes email controllers and views. So if you want an email system, this would be a good thing to look at. Test scripts, route configuration files. And then there's all these like Boss whatever services that do all kinds of neat things. We'll actually see some of those in action shortly here.
Is Boss DB a relational database, or is it like a document?
I believe it's relational. It just gives you some functions to be able to map stuff back and forth.
Is this related at all to JBoss?
I don't know. I don't think so. At least I didn't come across that, but it could be. I don't know. All right, so we'll just go ahead and start with our demonstration. So let's see. Let's quit our Erlang shell. Okay, so basically, let's go into new. Let's call it present. Okay. So in order to get Chicago Boss, oh, we're already in TMUX. Hub, this is the way I did it. And this is GitHub. Okay, so this will take a second, but basically it's going to clone into our repository. And then I'm also going to use oops. Our tree here. Okay. So this is our Chicago boss that we just downloaded. We'll go ahead and make. Oh, would help if we. I'm not sure what all those warnings are. It usually goes a little faster, so hopefully something's not amiss here. Could be.
Oh wait, you're building.
Yeah.
Yeah, so it's like initialized. It's so, yeah, so like getting home folders and dependencies.
Should be done soon.
How you liking the team hooks?
Not bad. Finally getting a little used to. Oh. Sure. I'm getting used to navigating between the windows. Took a little while, but oh, sorry guys, it's been really slow. Yay! So it gives us a nice little message. It says, all right, now you can make an app. So we're in the Chicago boss directory. We just do make app equals, we'll call it. And then we'll go into our demo. Oops. Don't want to go back there yet. So we'll go up directory. So we need to refresh. We'll go into demo. So we'll just take a little look. This is our. So we have our dependency. The ebin is the home of compiled modules, and also when it creates a .NET .app file, that's where it goes. It's not referenced in development, but when we go to actually deploy to production, then we want to populate those files using make stuff, because right now it's empty. So include has header files. You can also put application-wide macros and definitions in there. Log is exactly what it sounds like. If there's any errors or whatever, it'll log it in here. Private, at least I think that's what priv means. Sounds all special, but it's really a junk drawer of stuff that just doesn't go anywhere else. So yeah, so you'll have scripts, language files, rounding tables, static images, CSS, that kind of stuff. And then we have our source folder, very important. Here's where we'll see our MVC stuff. We'll write some controllers for an app. The lib folder is where you should put library modules, although when you're in development, they could potentially be recompiled with every request, so it's almost better just to, what did they say to do? Keep it outside your project directory and include the path to your server start scripts instead. So I haven't had to really deal with that for what I've been doing so far. Mail has all the mail stuff that comes with Chicago Boss. Models, where we'll put our models, obviously. Testing, we have e-units and functional testing stuff that we could do in there. Views are for templates that we'll create using the Django HTML. And then the demo.app our source produces an app file, and this will help the OTP do its thing that it needs to do. Actually, look at that one. So what else do we have? We also have our boss config. So it's just build tool configuration files. I'm sorry, this is setup, lots of different stuff. So we could say what database we want to use. Kind of looks a little funky. So if you're in Vim and you want highlighting, you can use set or I think it's file or but the short. And then this is an Erlang file. Some so you'll see there call this demo. Trying to find where our caching. We're not going to cache anything, but you could if you wanted to in here. The database, we're just going to use a dummy, like not a database. We'll just use an in-memory one for now. You could also choose which port you want to listen to. It's somewhere in here. So there's our port. So we'll be listening at 8001. So anyway, configuration file. The init dev sh, that's the dev server if you want to run it. You run the command. This one's the production one. You can look in there, but it's a little more verbose. But and rebar, let's see. Rebar and rebar config are actually the build tools and the configuration file. So those are the main parts of the Chicago Boss application. So we'll create a controller, and we'll call it the way you're supposed to call your controllers. It goes application name underscore controller name underscore controller. So application name is demo. Controller name, we'll call this greeting, and then the word controller. And then this will create a module, and we'll call it demo. And last time we said that you could do export and then name any functions or whatever. All of them, specifying which ones. And then we'll write a little function called, and this will take an and then we'll just pass in empty parameters. And this is just going to HTML. Okay, one thing that we didn't do, these are actually supposed to be parameterized modules, means that it has parameters in the module. Request object, so this will give us access to all kinds of information about the request. Okay, so we saved it. Now we can type in the name of the controller and the name of the action. We got a problem. So I thought it would log. Let me see. So I actually have, because I knew I'd be crappy at typing, a bunch of snippets that I'll use instead. Where's my... Oh, here it is. Okay. And for whatever reason, it always cuts off like... Okay. Well, no, it's not gonna work. Let's see.
So is that's Chicago boss saying we got a problem?
Yeah.
Does it ever give any more output besides that?
No, sometimes it gives error logs and stuff, but
Is that log folder not refreshing? Maybe.
yeah, I
a
wonder
log
if
in
there's a caching. No, there's no logs. I already tried to refresh it.
there? Okay.
There's also like some weird caching stuff that I've run into before, where even if I change a file and save it, it'll bring up the old stuff that I wouldn't expect it to bring up. So I wonder if it's
Do a force refresh.
Yeah. Is there a way to like stop and start?
yeah. Let's see if we can do something like that. So, oh, there's a very important part that we didn't do.
You need a view.
Nope.
Oh, yeah, because you're just spitting out.
And Joe kind of hit it on the head.
Actually starting the server.
Yeah. So that always
The
helps.
server's not started. Yeah. How did you get that page though?
Yeah.
Do you have like another demo?
I probably had something
running?
else going on there. So let's see. Init. I think it's just / init.
Mr. T.
Oh, thanks. There we go. All right. Now no one will ever forget to run the server again. Come on.
Well, you're getting something back from the server.
Yeah, so it's like you already had one running. Yeah.
We didn't use the port.
Yeah, 2001.
Let's change the port.
Yeah, we could try that.
2002.
So, oops.
Search. It's on line 4. I don't like that numbering thing. Yeah, it's weird. What's the actual line number? I don't even know.
Let's see.
It's right there.
So we'll just say 2002. I don't know.
Start it.
Okay. So Okay, we'll try to hit it at 2. There we go. Yeesh. All right. Okay. So there's also different tuples that you can use. Let's go back to our controller. If we wanted to do JSON instead, let me see if I remember how this goes. It's just right here. So sheesh.
I think you're missing a closing square. Okay.
Oh, I am right here. I put that in there. There we go. So that's how you can do JSON APIs using Chicago Boss if you wanted to. Because it actually converts it into JSON from the tuple. So it's that. So that's a little more useful than maybe just raw HTML, but you can also do templates. And with that, you just change it to OK. And the rest of it remains the same. So if we're going to use a template, so we'll see, since we don't have a template, it's like, I don't know what to do. So we'll have to actually go add one. For every controller, you have to add a subdirectory. So we'll add, and then we'll go into that. We'll add, it's called .h. Where's my it's not in there. Okay, that's okay. We can do something simple. So we would want, and then we got our hello in bold. You could also do filter, and then filters it up to uppercase. If you want to do more than one filter, you just pipe them together. And there's a whole bunch more you could do. So we've seen you can do output value, which returns raw HTML, JSON value. So basically all of these. OK is the template. So we said hello to the world, and now we need to know what to do if the world says hello back to us. So we'll create, this is where we'll talk about models. Maybe. Okay. Go. Thing is driving me crazy. So we'll go into a new one, we'll call it, and these are just rules. They seem like regular ones. Compiling special superpowers, basically. So rather than try to write that one, I think I do have a snippet. The first part's really simple. This was being a long presentation. First parameter that will pass it is always ID. On that, and then we'll just do our okay, so basically this is just a model for any greeting objects, a parameterized module with two parameters, ID and greeting text. So we can jump over to our
you don't have to do like greeting text, right? There's like just do text and there wouldn't be any conflict or something like that.
oh, instead of greeting text?
Yeah. Or is it you do that because of just Erlang itself?
Do whatever.
It's easier when you're like combining stuff together.
No, it literally could be whatever you need to be, as long as you have the ID as the first parameter. So it's just kind of up to you. Okay, so all right, so now we will call we need to create a variable new ID over there. Did I save that?
Running pretty short on time.
Okay.
That's your web server on the terminal.
Yeah, it's actually what we want to do.
Save the file.
Oh, I think there's one part I vaguely remember. We may have to go to our web browser. Let me see if this works. Okay, so that was it. I totally forgot about that.
This is your mock in the database that you're creating greetings into.
Yeah, so basically the reason I had to refresh the browser is it compiles it and makes sure it's loaded correctly. So before that, I didn't know quite what to do. So I'll just show one more thing and then we could probably wrap it up. So we've created this variable, and then we'll say greeting hello there. So you might be thinking, okay, we just called the greeting text function, but we didn't actually write any functions in our module. So that's kind of weird, right? That's where the superpowers of the model come in. The compiler actually adds a bunch of functions for us, which is kind of cool. And they're pretty useful too. You could do a bunch of other stuff. I have a bunch of examples. I'll kind of skip them for now, but jump over and maybe show one more thing. So another cool thing it generates is some documentation for you. And you can see that we have our greeting module. We have our demo greeting controller. If we go into greeting, here we can see all the functions that it generated for us. So here's our greeting text that we just called, and it returns a value of greeting text, which is pretty cool because this is all stuff that we came up with. It's not like, you know, it's documentation that generates. Pretty sweet. And then of course there's descriptions for all the other functions. But anyway, so that's the main basic, you know, controllers, models, views. I guess we'll end it there, but you can do a bunch of other stuff in Erlang that's hard to do in other languages. Essentially, you could do like a form where you could put in some type of greeting, keep a list. You can have these greetings like automatically update based on if the server changes or, you know, stuff like that. You have this concept called long polling, which essentially means that short polling is the traditional one that we're more used to, and that means that the requests every couple seconds and the server responds immediately every time. Whereas long polling means you send out a request and there's no response until there's something to respond. So that's nice because you can, well, the reason that they use the short polling is because that each process could take up a lot of memory, and if you have a bunch of processes that get locked up for long polling, then your system eventually could just crash. But with Erlang, since you have the actors and all that stuff, it makes it really easy to do that kind of stuff. Anyway, yeah, we're pretty much out of time, unfortunately. It's way overzealous. Include some resources in here for Erlang. So if you're interested, again, like the Learn You Some Erlang was probably the most useful one that I saw. And then Chicago Boss, basically everything on chicagoboss.org is pretty good. And you can almost go into his PDF that he has in his documentation section and just pick up where we left off. Create a pretty cool app. So, yeah, sorry that was rough and go, but.
Does Chicago Boss do anything to make working with strings any easier on Erlang? Because you said they don't really have a good string type.
Yeah, I think they have some things they can do, but I didn't really get into like specifics on it. I still think even with Chicago Boss that string manipulation just isn't like one of its strong points. Just because Erlang, like, I don't know, it's not a strong point in Erlang. So yeah. So there's pros and cons. I guess if you're writing a chat server or something of that nature, or like a social network, if you want to write a social network, then this would be a pretty good thing to look at. But after kind of going through it, you know, would we use it here? Probably not. I don't know. It just depends on the product that you're building or whatever. So, but anyway, I'll just leave it at that. Thanks. Where's my...
Oh.